Hi there, this is Mrs. Bracy and this is Trigonometry Video 5, and today we're going to talk about the law of sines and the law of cosines. We'll do our flashcard. We're just going to write down the formulas and then I'll do some examples from the packet and then we'll do some more work in class, alright? So the law of sines and law of cosines apply to oblique triangles, which we have learned just means that they're not right triangles. And I'm going to draw my flashcard here, triangle ABC. And as you know, the angles are capital letters and the sides are lowercase letters. Side A is across from angle A, side B is across from angle B, and side C is across from angle C, okay? And so, like I said, like we learned before, capital letters are going to be angles, lowercase are going to be sides. That's going to be very important to these new laws that we're learning. The law of sines is a proportion. So the law of sines is going to tell us that the sine of angle A over side A is in proportion to the sine of angle B over side B, and also in proportion to the sine of angle C over side C. Okay, so that's your law of sines. You would choose whichever two are going to be helpful to the situation that you have, and you would set up a proportion and cross multiply to solve. What you're going to note here is that if you are using the law of sines, it's always going to have to do with two sides and two angles. And of course, one of those things would be unknown so that we would be able to solve for it, but we would have to know the other three. And it's very important to note that it has to be sides and angles that are across from each other. If we know angle C and side A, those two things may not necessarily fit into the law of sines to help us solve for missing information. All right, the next is the law of cosines. And the law of cosines, and this is one where the letters are interchangeable, just like our area formula was. That's going to be a squared equals b squared plus c squared minus 2bc times the cosine of a. So that is side A squared is equal to side B squared plus side C squared minus 2 times each of those sides times the cosine of the angle that was across from the side that we put over here. Okay, so here's another situation where it's important to notice what you need and what angle and sides are across from each other, because this angle has to be across from the side that you put over here. So what we can really do is this can be rewritten with the other variables. So we can say b squared equals a squared plus c squared minus 2ac cosine b, or even c squared equals a squared plus b squared minus 2ab cosine c. It's really the same thing for all three situations. It just depends on the sides that you have. Notice that the law of cosines uses all three sides and one angle. Okay, so we're going to be using three sides and one angle. Okay, and so again, 4 pieces of information. One of those pieces of information would be missing to help us figure out what we need. Okay, let's look at a couple of examples. We're going to go to page 40 in the packet. And we'll start right off with number 1. This is law of sines practice. Number 1 tells us that in triangle ABC, the measure of angle B is 82 degrees, the measure of angle C is 36 degrees, and side A is 15 meters. We want to find the length of B to the nearest tenth of a meter. Side B is across from angle B, so I'm going to label that B. And so to use the law of sines, we need 2 angles and 2 sides, which we have. However, they have to be across from each other. So angle B is across from side B, so I can set up a ratio with those two in order to solve for side B. But I can't use 36 because I don't know the side across from it. What we can do, though, is we can solve for angle A and then set up the proportion using angle A and side A. So 82 and 36 add up to 118, and 180 minus 118 gives us an angle measure of 62 degrees for angle A. So sometimes you're going to have to do that little bit of work to find that missing angle. Okay, so now angle A is across from side A, and I can set up my proportion with these two angles. So I'm going to say that the sine of 82 over B, notice those are opposite each other, equals the sine of 62 over 15. Again, the two that are opposite each other. Kind of color-coded that for you. Now you can cross multiply, and it's going to be a really good idea to leave these numbers exact instead of rounding in our calculator. This isn't going to be too bad. B times the sine of 62 is just B sine 62 equals 15 times the sine of 82. Instead of multiplying them, I'm going to just leave it like that. Then I can divide both sides by the sine of 62. And now what I can do is type this into my calculator exactly as it is to get the most accurate approximation of side B. Okay, so when you type that into your calculator to the nearest tenth, you will get 16.8 meters for side B. Okay, moving on, we're going to actually flip the page here and look at number 8. On page 41, there we are, and number 8 gives us triangle ABC and asks us to solve the triangle. Solve the triangle means to find all three sides and all three angles of the triangle. And they do tell us that we can round to the nearest tenth or nearest degree. So we're going to go ahead and use the law of sines to help us here, and we can do this in whatever order we want. You might notice that you have a 50 and a 35, and so you can easily add those together and subtract that from 180 to find out that the measure of angle C is 95 degrees. That's pretty easy to do right off the bat. And then you can decide which proportions. You're going to have to do two different proportions to solve for the two different sides. As we have been talking about all along, it's best to use given information when possible. So I'm going to use the sine of angle A with the side of 12 for both of my proportions to solve for both B and C. I'm kind of split my space in half here. So I'm going to say that the sine of 50 over the opposite side, which is 12, equals, let's go with B, since that's in alphabetical order, we'll say the sine of 35 over side B. And now we can cross multiply to solve for B. So B times the sine of 50 is equal to 12 times the sine of 35. Again, we're going to divide here. We're going to divide by the sine of 50. And again, we're going to type this into the calculator as it is. To the nearest tenth, you're going to get 9.0. Okay. To find side C, I'm again going to start with the sine of 50 and 12 because I'm going back to given information since that's possible here. So the sine of 50 over 12 equals, this time I'm looking at the sine of 95, and here we're not using given information, but hopefully we did a nice job solving for that angle because that wasn't too difficult of a computation. And that's going to go over side C. And then we can go ahead again. Same exact process. You're going to see as you do this, it turns out to be a very similar process every single time. So C times the sine of 50 is equal to 12 times the sine of 95, and divide by the sine of 50. And my answer was 15.6. Okay, so we were asked to solve the triangle, and since we were given 3 of the measures, we then found the other 3, and we have solved the triangle. Okay, it is possible to look for a missing angle using the law of sines, and we'll look at that situation next class. We're going to look at a couple examples right now with the law of cosines, and I'll show you how to find a missing angle there. so you can kind of see how that will work. Let's look at page 42. We're going to start with number 1. So now we have triangle ABC with angle A being 40, side B equals 16, and side C equals 20, and we want to find side A. Remember, the law of cosines is 3 sides and an angle, and luckily here we have the angle included between the 2 sides that we already know, so this is going to be easily set up for us. We're going to say that side A squared equals side B squared plus side C squared minus 2BC cosine capital A. Again, you want to make sure that your side that's over here is across from the angle that you put here. So let's fill in what we know. We do not know side A, so A squared equals, side B would be across from angle B 16, side C would be 20, and we fill those numbers both in again. So 2 times 16 times 20, 0, cosine of, and we know that the angle is 40. Now here's cool news. This whole thing can be typed into your calculator as it is. If you do that, you find out that A squared is equal to 165.732, and your calculator might go out further. Mine actually stopped at 3 decimal places. And so now to get A, we're obviously going to take the square root on both sides, okay? So if I go ahead and square root both sides, I'm going to find out that A is equal to 12.87, and to the nearest integer, A is going to equal 13. Okay, so that's how you figure out a side. And the next thing we're going to do is figure out an angle. So let's look at number 2. We have triangle ABC. The sides are 11, 16, and 20. Find the measure of the largest angle in the triangle to the nearest degree. So if we think back to when we learned about triangle inequalities, we learned that the longest side is across from the largest angle. So the longest side is 20, which means angle B is going to have to be the largest angle of the triangle. So now I know that I'm solving for angle B. So we're going to use B squared equals A squared plus C squared minus 2AC cosine B. Okay, once I determine which letter I'm putting here, then I just know the other 2 letters have to be replaced in here. So we know side B this time, so now we know that 20 squared is equal to, across from A is 11 squared, plus across from C is 16 squared. Again, we multiply those both by 2 in the second part here. Cosine of, we do not know angle B, so let's leave it as capital B. This time it's a little bit more math to do to fill this out, but it's not too bad. 20 squared is 400. 11 squared plus 16 squared, I just went ahead and typed that in my calculator to get 377. And 2 times 11 times 16 I typed in my calculator to get 352. And so now we have essentially a 2-step equation. We're going to subtract 377 on both sides, which will give us 23 equals negative 352 cosine B. Don't let this negative scare you. It seems like, oh, we shouldn't have negatives in trigonometry. But it is possible to have negatives, and your calculator will still tell you the angle that you get when you have negatives. So really, you don't even have to worry about that part. You're just going to keep going like normal. And we don't want to do anything with this fraction. We want to just leave it as it is. So we now know that the cosine of B is equal to, you can put the negative out front or you can leave it with the denominator, whatever works better for you is fine, negative 23 over 352. If this is a reducible fraction, you may reduce it, but don't turn it into a decimal. Leave it as this fraction. And so now you're going to go to your calculator and you're going to type in the inverse cosine of negative 23 over 352. And when you type that into your calculator, you'll get the angle measure for B, which is 94 degrees. Okay, so we're using inverse cosine there to finish that up. So this is not by any means everything that has to do with law of cosines and law of sines, but here's a good sampling, and we'll look at some more examples next class. See you guys then.